number 6, which is fine. Okay. So 6, we're doing g of -2. So we'll start by just kind of drawing in our...
Mr. Cooley,
Yeah.
did you share your screen yet?
No, not yet.
Oh, okay. Copy that. I shouldn't see anything. All right, thank you.
Yep. Okay, and then we'll put in our coefficient. Notice that I put the 0 in for the missing x squared term. And then you just begin by bringing the first number down. -2a times -3 is +6a. And I add down. And 1 and 6a aren't like terms, so they can't add together. So then if I do -2a times 1 plus 6a, that gives me -2a minus 12a squared. If I add down, again, no like terms, so they don't add together. And then I multiply -2a by this stuff. Give me -2a 4a squared. Plus 24a squared, or a to the third, excuse me. And I add down, but 0 doesn't matter. And I multiply the -2a again. And we add down. And then one more time, multiplying by -2a. Oops. And add down. There you go. Sergio, you okay with what we did there?
Yeah, thank you.
So again, still the same.
I just roll, so.
Yep. Amy, you wanted to do number 8. Okay, so
yep.
We'll set this up. The divisor is going to go on the outside of our division bar. And then the dividend is going to go underneath. That's our initial setup. Okay. And then we'll ask ourselves, how many times does x go into 2x to the 4th? Well, that would be 2x to the 3rd, because 2x to the 3rd times x gives me 2x to the 4th. So multiply that to both parts of the divisor. And we'll subtract down. I like to distribute through the negative. rather than trying to treat it as a subtraction problem. So 2x to the fourth minus 2x to the fourth is 0. Negative 9x to the third plus 10x to the third is 1x to the third. We'll bring our next term down and then go back to the top. So we're going to ask ourselves how many times does x go into 1x cubed? Well, that's x squared, because x squared times x gives me x to the third. So multiply that to both parts of the divisor, and then subtract down. And again, I like to distribute the negative through. X, 1x cubed minus x cubed is 0. Negative 12x squared plus 5x squared is negative 7x squared. And we'll bring our next piece down. And then go back to the top. Ask ourselves how many times does x go into negative 7x squared? Well, negative 7x, because negative 7x times x gives me negative x squared, or 7x squared. And multiply through. And then subtract down. Again, I like to distribute the negative, so negative of a negative is positive. And then negative of a positive is negative. And negative 7x squared plus 7x squared is 0. 29x minus 35x is negative 6x. And then I'll bring my last piece down. Ooh. And then my last question here is, how many times does x go into negative 6x? Well, that's just negative 6. So I'll multiply to both pieces. And then subtract down. Distributing through the negative. Negative of the negative is positive. Negative of a positive is negative. And when I add those up, I get 0. So this is just remainder 0. So we'd say our answer is just 2x cubed plus x squared minus 7x minus 6. Since the remainder is 0, I don't have to worry about any other part to it. Amy, are you happy there?
Yep, thank you.
You're welcome. Anyone else with questions from the homework?
I just had a question.
Okay.
So, like, for number 4, when you don't get, like, perfect diagonals, like, when you're adding the like terms at the end.
So if you include, if you include the zeros for the missed terms, all like terms will line up on diagonals. If you forgot to include the zeros for the missing terms, then things probably won't line up for you.
Okay, yeah, that's what I did wrong.
Okay.
Thank you.
So it doesn't make it incorrect. It just makes it a little more inconvenient. So adding the zeros in there really makes a big difference, because then you don't have to hunt through to find your like terms.
Okay, thanks.
You're welcome.
Mr. Kulik,
Yeah, Amy.
could you do number 10? I was just confused on how to deal with like the x squared plus x minus 6.
Okay, it's no different. So let's just set it up maybe over here. And then we got some missing terms here. So I'm going to make sure I put those zeros in. Okay with that setup there, Amy?
Yep.
Okay. So we'll start the same way. We're just going to ask how many times does x squared go into x to the 6th? Well, that's x to the 4th. I'll just distribute that to the whole divisor. And then subtract down. Distributing through our negative, I get a negative, I get another negative, and then I'll get a positive. So when we add down, we'll get negative 5x to the 5th, or negative x to the 5th, negative 8x to the 4th, and then we'll bring down our next one. And we go back to the top. So we're looking for how many times is x squared going to negative x to the 5th. Well, that's negative x to the 3rd. And again, we'll distribute that to the whole thing. And then subtract down. Distribute through our negative. Negative of a negative is positive. Negative of a negative is positive. Negative of a positive is negative. And then you add down, so 0, negative 7x to the 4th, negative 6x to the 3rd. Oops, we've been writing those in black though, huh? Might as well keep the color coding going. Okay. Ask ourselves how many times is x squared going to negative 7x to the 4th. Well, that would be negative 7x squared. And again, multiply to the whole thing. And subtract down. Distributing through our negative. Negative of a negative is a positive. Negative of a negative is a positive. Negative of a positive is a negative. Adding down 0, 1x to the 3rd, 7x squared. Bring the next one down. And then back to the top. How many times does x squared go into x cubed? Well, that's just x times. Multiply it to the whole thing. And subtract down. Distributing through our negative, I get negative and then positive. So I have 0, 6x squared, 6x, and I'll bring the 36 down, or negative 36 down, I should say. We'll go back to the top and ask ourselves how many times does x squared go into 6x squared? Well, just 6 times. Multiply that through. Distribute the negative. And then add down, gives me 0 again. So this piece is just going to be my answer. So you see, Amy, it's still just exactly the same process as the other one. You just, instead of getting 2 things underneath that you're subtracting, you get 3 things. But it doesn't make a whole lot of difference, right? Okay. Cool. Any about this homework here? Great. So today we're going to talk about 2 things.
Mr. Cooley,
Yeah.
I don't need to be recording.
Well, okay. No, it's going. So the first thing we'll talk about is a shortcut to polynomial division. So this shortcut is called synthetic division. But like any shortcuts in mathematics, we wouldn't call it a shortcut if it worked all the time. It's only going to work under certain special circumstances. Or else we would just call it the regular method, right? We wouldn't give you a shortcut if it worked all, you wouldn't call it a shortcut if it's what you could use every time. So to do synthetic division, we have to have a divisor with degree and leading coefficient equal to 1. So if we go back and we look at the problems in the homework that we did last night, if I look at the divisors for number 8, well, the leading coefficient is 1 and the biggest exponent is 1. So we could use synthetic division on this problem. If I look at number 9, the leading coefficient is 1, the biggest exponent is 1, so I could use synthetic division on that one. If I look at number 10 though, the leading coefficient is 1, but the degree, the biggest exponent is 2, so I can't use synthetic division on that problem. Okay, we haven't talked about how to do synthetic division, just when we can do synthetic division. But it's pretty easy to tell right away by looking at the problem whether you can use it or not. It just takes a second. All you have to do is look at the divisor. So let's do an example here. Since we've done 8 in the homework, and then again as a example problem here just a moment ago, let's show you guys how to do the synthetic division using number 8. Okay. So the first thing we're going to do is we're going to start by taking the divisor, setting it equal to 0, and then solving. It's pretty trivially easy to do. And we're going to set up a substitution problem where that value that we just solved for is the number on the outside, and the coefficients of the dividend are going to be the numbers on the inside. And notice I didn't have to include any zeros because I have no skipped terms. Everybody okay with the setup? Pretty easy, right? Basically, this is still the same setup as synthetic division, or synthetic substitution, excuse me. And the process now to do the synthetic division is exactly the same as the process for the synthetic substitution. So I'm just going to start by bringing down the first number, and we'll multiply the number on the outside by the number underneath, write it in the next open spot, and add down. And I'll just kind of continue that process, just like I would for synthetic substitution. And we're done. The synthetic division is over. I've completed the process. And you're looking at me going, wait, what? Well, it's done if you know what to, or how to interpret these numbers at the bottom. So the way we're going to do this is we're going to start at the far right. The number at the furthest right is always going to be the remainder. The next number is going to be the constant term, and then the x coefficient, and the x squared coefficient, and the x cubed coefficient. And as we move from right to left, the degree of our x is just increases by 1 each time. So if we do this then, we'd say the answer is 2x cubed plus x squared minus 7x minus 6. And then we could write plus remainder over divisor, but since the remainder is 0, I don't need to do that. And we're done. Boy, that was a lot faster and a lot easier than the regular long division. It took up less space. There's less places to make little silly arithmetic errors. There's less sign flippings going on. Overall, like, I think considerably an easier process. Let's do another example. So let's say we're going to do 6x to the 5th minus 4x to the 3rd plus 7x squared minus 10x divided by x plus 2. Start the same way. Set the divisor equal to 0 and solve for x. We'll then set up a synthetic. We put that solution on the outside. And then inside of our synthetic substitution problem, we're going to use the coefficients from the dividend. So it starts with 6, and then I need to make sure I have my 0, since I have no x to the 4th terms. And then a negative 4, and a 7, and a negative 10, and I need another 0 at the end, because I have no constant term at the end. Very easy to forget to do that one. So please be careful there. So that's the setup. Everything's ready to go now. So just bring that first number down. Negative 2 times 6 is negative 12. Add down. 2 times negative 2 times negative 12 is positive 24. Add down. Negative 2 times 20 is negative 40. Add down. Negative 2 times negative 33 is negative 66. Add down. And negative 2 times negative 76 is positive 152. So remainder, constant term, x coefficient, x squared coefficient, x to the 3rd coefficient, x to the 4th coefficient. So we'll say our answer is 6x to the 4th minus 12x to the 3rd plus 20x squared plus 33x minus 76 plus our remainder, which is 152, over our divisor, which is x plus 2. And there's our
Mr. Cooley,
final answer. Yes.
would that be a 6x to the 5th?
No.
Or-
Should be x to
No.
the 4th.
Wait, why? Oh, wait, did I look at the wrong one? No.
Well, if I divide x to the 5th by x, the quotient should certainly not be x to the 5th again, right?
Yeah.
If you look at the problem, we're taking an x to the 5th and dividing it by an x to the 1st. Should be an x to the 4th, right? Should always be 1 degree less than whatever your dividend was.
Okay. All right, thanks.
Yep. But in general, we're counting from the right to the left, you have to remember remainder comes first, and then a constant term, and then x squared next to the third, and so on.
Mr. Kulik,
Yes.
for just the x to the first number, wouldn't that be negative 33?
Oh, sure. So that changes a bunch of stuff, huh? Thank you. Would have been nice if you mentioned that earlier. I'm just giving you a hard time. Thanks. Sorry about that, folks. I'm glad you caught it, though.
Mr. Kulik, wouldn't that make it negative 112?
Sure. You got it. Okay. Questions about this process? It's really quite lovely, right? It speeds things up enormously, and it, as we'll find out in second semester, dividing a polynomial by these little linear terms is going to be fundamental to some of the factoring techniques we talk about in second semester. So we're going to get a lot of use out of this synthetic division process as we continue through this chapter 5. Now we won't see that here before the end of the semester because we have just one more class period after this one. But when we come back in the winter, we're going to spend a lot of time using synthetic division to do some factoring techniques here in second semester. So it's quite a nice, efficient method, which is great, right? Like, we like things that make our lives a lot easier. Okay. Next up, we're going to talk about some polynomial factoring techniques. So we're going to look at a couple of these today, and we'll finish up the rest of them in our next class period and talk a little bit about solving in that class period as well. So the first one that we're going to talk about are the sum and difference of two cubes. Oops. So the sum of two cubes will factor this way, and the difference of two cubes factors this way. So let's do a little example to kind of get you a feel for how that's going to work. So let's say we have x cubed minus 8. Well, this looks like it could be a difference of two cubes because I have two things that are being subtracted, and the exponent on the variable is divisible by 3. So I'm going to try to rewrite x cubed as something to the third power. Oh, that's just x to the third power. Then I want to rewrite 8 as something to the third power. Well, I know 2 times 2 is 4, and 4 times 2 is 8. So 8 has to be 2 to the third. So if I look, this does match the form of our difference of two cubes, where in our case our a is x and our b is 2. So I'm just going to fill those in then for the a's and b's in the other half of my factoring pattern. So I have a minus b, a squared plus a times b plus b squared. And that will clean up to just x squared plus 2x plus 4. Let's do one more example, and then we'll talk about the next type. So maybe we have 64x to the third plus 125. So again, I look at this and see that x to the third and just the two terms there. So I think, well, maybe this could be a sum of two cubes. But in order for that to be the case, I'd have to rewrite the 64x to the third as something to the third power. Well, I know 64 is, well, 4 times 4 is 16, and 16 times 4 is 64. So I could rewrite 64x to the third as just the quantity 4x to the third. And then 5 times 5 is 25, and 25 times 5 is 125. So I can rewrite 125 as 5 to the third.
X cubed plus 5 to the third.
Is there a question? Somebody turned on their microphone here to talk to me. No? Okay. So if I look at this, this is now definitely in the form of our sum of two cubes. So I can just fill it into the formula where my a is 4x. So 4x plus 5 times 4x squared minus 4x times 5 plus 5 squared. And if I clean that up a little bit, 4x times 4x is 16x squared, 4x times 5 is 20x, and 5 squared is 25. Okay. Any questions about using this? The next one, and this is a factoring pattern that we saw already in the previous chapter, but we can now use it to do factoring on things that are not just quadratic. So let's say that we have x to the fourth minus 25. Since we have that x to the fourth in there, we definitely know that this is not quadratic, right? But I'm still going to approach this the same way. I'm going to try to rewrite x to the fourth as something squared. Well, I know x squared times x squared gives me x to the fourth. So x to the fourth can just be x squared squared. and 25 is 5 squared. So that meets the form for a difference of 2 squares, where my a is x squared and my b is 5. So that's going to give me x squared minus 5 times x squared plus 5. Let's say this time, though, we had x squared minus 16. And you might say, oh, I get it. It'll just be like x squared minus 4, x squared plus 4, right? Using the same kind of technique we just did before. And I'd say, well, you're almost finished. There's still some more we can do, though. If you look a little bit closer, you'll notice that x squared minus 4 is also factorable. But note that x squared plus 4 is not. There's no sum of squares factoring pattern. So we would need to make sure that we factor the x squared minus 4. Oops. But not do anything to the x squared plus 4. This is our final answer. Oops, I wanted to do that in a different color. We'll do one more here. So what if we have x to the 6th minus 1? Well, again, I want to try to write this as something squared minus something squared. So I know x to the 3rd times x to the 3rd gives me x to the 6th. And 1 times 1 is still 1. So I can write this as x cubed squared minus 1. So my a here is like x to the 3rd, and my b is 1. So using my difference of 2 squares, I can write x to the 3rd minus 1 times x to the 3rd plus 1. But I'm not done here. If you look closely, x to the 3rd minus 1 is a difference of 2 cubes, where the a is x and the b is 1. And x cubed plus 1 is also a sum of 2 cubes, where the a is x and the b is 1. So I apply my difference of 2 cubes. Get this, and I apply my sum of 2 cubes. I get this, and if I clean all that stuff up, I get this guy as my final answer. Okay. Any questions about kind of using this difference of 2 squares? It's still the same idea as last chapter, but you then have to look at what you got to see if you can do any more factoring afterwards. Okay. Okay, so the last type of factoring I want to talk about today is something in the quadratic form. So if I have something that looks like a times x to the 2n plus bx to the n plus c, I can just try to use my techniques that I used for factoring quadratics from the previous chapter. So let's look at a couple of examples on doing that. So let's say we have x to the 4th plus 5x squared plus 6. I notice that 4 is twice 2, and then there's no variable on the last piece, so it does fit this form. And what I'm going to try to do now is I'm going to write this as like a quadratic. So x to the 4th is x squared squared. And then we have 5x squared to the 1st plus 6x. So if we suppose that y is equal to x squared, and we make that substitution, we have something that looks positively quadratic, right? Y squared plus 5y plus 6. And now I can just use my shortcuts from the previous chapter. So two things that multiply to give me 6 and add to give me 5 are 2 and 3. But remember, we're not factoring for y, we're factoring over x. So now that I've used that quadratic technique, I'm going to go ahead and substitute the x squared back in for the y. And then I should check to see if there's any more factoring I can do. X squared plus 2 I definitely can't factor because I can't do anything with a sum of squares. And x squared plus 3 I can't factor anymore because I can't do anything with a sum of squares. Any questions on that one? Okay. Let's do another. So let's say we have 8x to the 6th plus 63x to the 3rd minus 8. So again, I notice that this is in the quadratic form because my biggest exponent is twice my second exponent, and I have a constant term. So I'm going to rewrite this as 8x cubed squared plus 63x to the 3rd to the 1st minus 8. And then just like before, I'll make a substitution so that I can write this as something fully quadratic. So how do I factor something like 8y squared plus 63y minus 8? Notice that my leading coefficient isn't 1, so I can't use one of my shortcuts here. I'm going to need to find the two numbers that multiply to give me 8 times negative 8 and add to give me 63. So hopefully it's not hard to see that's going to be 64 and negative 1. So I can rewrite that as that. And I can take a greatest common factor of 8y from the first group and a greatest common factor of negative 1 from the second group. Both groups have a y plus 8 in common. So if I factor that out, I have y plus 8 times 8y minus 1 And remember, we got to put our x's back in. So we have x cubed plus 8 times 8x cubed minus 1. And if I look closely at each of those, you'll notice that they are both a sum or difference of 2 cubes. So there's more I can do. So here it should be easy to see that my a is x and my b is 2. Here as well, it should be easy to see that my a is 2x and my b is 1. So the first factor becomes x plus 2 times x squared plus x times 2 plus 2 squared. That's the sum of 2 cubes factoring pattern. And the second factor becomes 2x minus 1 times 2x squared plus 2x times 1 plus 1 squared. That's using our difference of 2 cubes factoring patterns. And then we get the following final answer. Okay. Questions on this one? Okay. Well, that's as much as I wanted to do today. Your assignment is in the content library. If you look at Chapter 5, Homework 2, I have 4 problems that I ask you to do using synthetic division, and then 6 problems where I ask you to factor using these sum and difference of 2 cubes and difference of 2 squares factoring patterns. And the last thing to do for today is going to be our final homework quiz. So this is also in the content library. So before the end of the day, I need you to complete this homework quiz and submit it to the Dropbox on PowerSchool. So there's an assignment created in PowerSchool called Homework Quiz 6. You'll just submit your answers to that. If you do your work in OneNote, please convert it to a PDF and put it in and upload that file into the Dropbox. If you did it on paper, you can just take your picture and upload your picture file into the Dropbox. But please make sure you do that today. This is the final homework quiz assignment. And I'd like to have these in and done and graded by tomorrow morning so you guys can see what's going on with your grades and stuff. Okay? Any questions on either of that? Okay. Well, you guys are dismissed, so go ahead and type bye into the chat. You can get started on your homework quiz and homeworks, and have a nice day, and we'll see you guys on Monday of next week. Take care. Be safe. Enjoy.
Thank you. Bye.
Yeah, you're welcome. Goodbye.